Nicromet is a company which has been created 7 years ago to deal with refractory ores, that is, ores that do not lend easily to the extraction of values by the classical approaches. There are two types of ore that we have examined, the oxide type of material and the sulfides. Here at this pilot now, we are demonstrating at the ton scale the performances of our process working with the oxides.
This plant is a pilot plant to test a new process to produce nickel. And we also will produce a subproduct like magnesium chloride and potassium sulfate.
Nickel is an essential constituent of all the stainless steel or the high quality steel products, and this is a market which is growing at a tremendous rate, particularly in developing countries like China and India. The second product, potassium sulfate, is a fertilizer which is absolutely essential for the so-called intensive culture, where you have to apply a large amount of fertilizer. And if you use the chloride form of potassium, you will simply sterilize the fields. So people doing intensive culture has an essential need for potassium in the form of sulfate rather than chloride. Finally, magnesium chloride is the key product to gain access to all derivatives of magnesium, like magnesium oxide, which is an essential refractory for making steel, for example, for neutralization, control of the environment, and anti-acid, to that matter. And magnesium chloride can be used as such for prevent icings on road without polluting the environment. That's a trend which is very strong at this time and is creating a huge market for mag chloride.
First part of the process is completed right now. We've started first series of tests already. Showing good result, very promising result, and we're still in the construction for the second and last part of the process, which will be completed, we're planning, by the end of May, so 1 month from now.
This pilot is oriented to the validation or the extraction of nickel from serpentinic tailings, which are extremely abundant, 3/4 billion tons available in this immediate area. And this is the rationale for being here very close to these tailings. We can deal with a material bearing nickel that also is very rich in magnesium, aluminum, and calcium. There exist, of course, technologies for the recovery of nickel from ores, particularly the oxide ores or laterites, but those existing techniques cannot give interesting results, in fact cannot perform at all when you have a magnesium content above, let's say, 3-4%. Well, here we succeed in achieving excellent yield of recovery with a material which contains up to 20% magnesium. So that will be a key to transform sterile stone rich in nickel into a very profitable ore, because we have the technology to extract that nickel at very economic prices with an ore that would be otherwise unsuitable for treatment. The abundance of the material make it very interesting. If we succeed, you will have access to tonnage of nickel with a value in the range of $20 billion US. So the potential here for the validation of this mineral material, which stands idle at this moment, will be tremendous. And this material is already mined on the ground. It has been reduced in size to a substantial degree. So we start from this type of rock here, which varies from 1 inch in diameter down to rather fine dust. And we apply the standard technology to reduce that to the proper size that we need for the acid digestion, that is from minus 35 mesh to down 200 mesh. Overall, this process is a hydrochloric lixiviation. Why did we select hydrochloric acid? Because this is an extremely efficient acid to get at the values. Hydrochloric acid is an acid which is relatively expensive when related to sulfuric acid, which is much more common and much cheaper. So in part of the process, we generate ourselves the hydrochloric acid that we need, and we do that by reacting the cheap and abundant sulfuric acid with another mineral which is extremely abundant in Canada, that is potash, or potassium chloride. In that fashion, you generate the hydrochloric acid you need, and you have a secondary product, which is potassium sulfate. Then when you have this hydrochloric acid, you get it first in a gaseous form. You react it with your material in this gaseous form. This helps tremendously to achieve a very high degree of reactivity. You terminate by vat leaching, and using state-of-the-art technology with ion exchange resin, you selectively collect the nickel, then remove the iron from the resulting magnesium chloride and have a magnesium chloride or derivative of the magnesium chloride as a secondary product. So all these things put together give you an excellent economics and a very good performance. Mine has gained a very bad reputation by pollution it has created around the deposit or around the plants working with the ores. In our case, we have here a wet technology with complete recycling of water and with no gas emission at all. So there is here no tall chimneys, there is no scummy water flowing into rivers here. So we do essentially very green chemistry by recycling of all the water and having no effluent in a gas form. As the Nicoromet developed its technology over the last 7 years, we have filed patents in several countries, Canada, of course, the United States, Mexico, and the belt where you find laterites, Cuba, Indonesia, Brazil, and all the near equator countries. Some of those patents have been issued and the others are pending but going well. When you look at the potential of the market of this technology, for example, to validate the nickel deposits which are hampered by the magnesium problem, you can see that in some countries, by the implementation of the technology, overnight you would double or triple the reserve of nickel ore. This is something with a tremendous impact on the industry of nickel. So you might do maybe a good investment in hitching your wagon to that technology.